Alright, so for today we're going to talk about statistical power. And we'll go over this with an example over here. I have talking about SAT math scores. And the applet you see on the right hand side there, I'll put the link to that down below in the description. So let's go into this example here. So the national mean score on the math portion of the SAT is 511 with a standard deviation of 120. We believe the students at VMHS have a higher mean than the national average. To find out, we take a random sample of 8 students and find their average. We will then use the data to conduct a significance test with a significance level of 5% or 0.05. So to start here, let's talk about our hypotheses according to this for the significance test, as well as define the parameter that we're going to be talking about with this. So first off, we should have our null hypothesis. Okay, we have our null hypothesis, in which case it said the mean average for SAT on the math portion is 511. Okay, now we said that we believe that the VMHS has a higher than the national average, so our alternative is simply greater than. So our mean, so our mu is greater than 511. Okay, so now let's talk about our parameters. So the parameter, what we're talking about, what is the mu representing? Well, that's the true mean math SAT score at VMHS, right? So it's the true mean math SAT score at VMHS. That's what our mu is talking about here. Okay, so suppose the mean math SAT score at VMHS is 535. So right there it's showing we're greater than the average, the national average, right? So we're going to go to the applet over here, and we're going to enter the information in here, and we're going to see what power we have. So over here in the applet, the mean for our null is 511. Okay, our alternative is greater than, it's already selected. Our standard deviation we had here was 120. And our sample size, we said we had 8 students. Okay, we had 8 students. Okay, our significance level was 5. Now the only other difference here is our alternate mu. In other words, the mean value that we had at VMHS. So our math scores were 535. And we hit update. That gives us our power. So over here, now based off here, the top graph is based off the mean of 511. So I know it's not listed here, but the actual mean value is right in the middle of 511. I don't put that right in the middle there, but it's 511. Approximate normal distribution there with the yellow shaded area. The yellow shaded area is talking about our 5%, right? So that's the 5%. That's your type 1 error. So in other words, you reject the null, however the null is true. So that happens 5% of the time. So that's what that yellow is referring to on the top there, okay? And again, the middle point of that is the mean point of that top one is at 511. Now, if we look at our data for the mean value we got for our SAT math score, we said was 535. Well, that's on the bottom graph here. So on the bottom graph right here, the mean value right in the middle, now our middle mean is 535. Well, according to the value that we got up here, according with the 5%, it comes down. Now the red is a little bit bigger. In other words, that is saying that we are going to reject the null, okay? So reject the null hypothesis. In other words, we have a 14% chance of rejecting the null hypothesis and saying that we're going to get a higher SAT math score according to the data that we collected from us. Okay? So that's what's talking about the power with that. Looking over here at the SAT stuff, it says what is the probability the test will find convincing evidence against the null hypothesis. So again, that's looking at your power, okay? So we're talking about that being your 0.14, okay? So with a probability, let's talk about probability right here. It's wanting to know the power, okay? What is the power that the test will find convincing evidence against the null, okay? So in other words, we have 0.140. So we have a 14% chance that we're going to reject the null and show that we actually get a higher SAT score for the math portion, okay? Now, interpret that. So let's interpret that. Maybe it'll make a little more sense after writing it out. So if the mean SAT score at VMHS is 535, so if it is 535, there is a 14% probability of the test giving convincing evidence for the alternative hypothesis of our mean being greater than 511. Okay, so the alternative hypothesis, that's what it's giving us. For that setup, they're saying that we have our mean is greater than 511. So now let's look and see what we can do if we want to increase that power of our test. And how can we adjust those following factors to do so? So we can just use the applet over here to determine that. So let's look at that. So with this, let's see what would happen with sample size. So we got sample size of 8, and we're at 14%. So let's go down. Let's say we got 5. If we go to 5, oh, that lowered the power. So let's say we go up to 28. Let's say we had 20 people to our, that jumped it up to 0.279. So 27.9%. So increasing our sample size definitely increased our power. So increasing sample size. Okay. Now let's see with our alpha level. So our significance level. Well, since we're at 27.9, what happens if we decrease it? Well, if we decrease our significance level, our power decreases as well. However, if we go from 0.05, 5%, we go up to 10%, the power increased. If we go up to 20%, power increased again. So increasing our alpha level as well. So we want to increase this guy as well. Now, if we were to, I was talking about the alternative mean here, so in which case we have 535. So the biggest thing here to look at is we're talking about if we want to increase the distance between the null and our alternative mean, or if we want to decrease the distance between them. In other words, if we want to go from 511 to just, let's say, 520, what happens to our power? Our power decreased. So when we decrease the distance between those values, the power decreased. However, if we went up greater than 535, let's say we went to 550, well, that increased our power dramatically as well. So in this case, you want to increase the distance between. So increase the distance between our alt mean and the null value. So, and the null value. So if we increase that distance between those two values, our power will increase. If we increase the significance level, our power will increase. And if we increase the sample size, our power will increase. Alright? So those are the big things to take away from this and talk about the power. Alright guys, so I hope you learned a little bit of something, and I'll see you next time.